Okay, let's see if we can do this quickly. And I think I'm going to change one of the problems. I didn't like one of the problems, Roy. I'm going to find it better. So there might be one new one for you guys. Okay, number one. See how the angle is already given in radians? Look, what is this? 7, 7, that's 2 radians, and that's S. So find the arc length. So what are the, no, and I decided I'm not going to give you the formulas on the test. You need to know the formulas, because on the final exam, and when you go to pre-calculus and calculus, they're not going to be given to you. So for this problem, this is what you need to know. So to find the arc length, it's simply the radius times the angle in radians, and that's 14. Finish. Except tomorrow, I think I'm going to put like 2.173 or something. Yeah, you have to calculate it for the whole test. Okay. And then this one, 1/2 the radius squared times theta, but it's in radians already. So the double, and you get 49. And I'm not even looking for units, because a lot of you put units here and then square units. I'm assuming we know how to do units already, so you don't even have to put units. Right? We're trigonometry. I don't know what that means. Okay, now 2A. You have to prove to me that you can work with degrees, minutes, and seconds. Okay, so we got a right triangle. What do we got? 28 degrees, 34 minutes, and 19 seconds. This is x and this is 4. So since this is the angle you know, what is this? This is opposite and hypotenuse. Which of the three has opposite? Okay. So sine of 28 degrees, 34 minutes, and 19 seconds, that's equal to opposite over hypotenuse. So therefore x is equal to 4 times the sine. Now how do you punch this in on your calculator? What do you do? Did anybody figure out this button yet? Just by experimenting or looking it up on Google? Okay, suffer then. So you gotta go 28 plus 34 over 60 plus 19 over 3600. You're just gonna have to do that on one problem tomorrow. You guys can handle that?
Yeah.
And then times it by 4, bam, that's your answer. And please, round off correctly. Because every time you round off, if you're wrong in the third decimal place, it's going to be -1 now. You don't want that to happen. Okay, here's the next problem, 6. And then I'll just do normal angles, like 50 degrees, or maybe I'll give you 1 decimal place, like 42.7 degrees or something like that. So here's the angle. This is adjacent, that's hypotenuse. What do I use?
Cosine.
Cosine. So the cosine of 50 degrees is equal to adjacent over hypotenuse. And then by now, after doing all the homework, can you guys do this by now? X equals 6 over cosine 50?
Yeah.
Or do you have to go step by step? Multiply the x over here first and then divide by cosine 50. I don't care what you do, get that, punch it in on your calculator, boom, you get your answer. Make sure your calculator's in degree mode. Now put it now and don't change it. C. Okay, so this first page should be pretty easy. Unless you didn't do it. Oh, that's an ugly right triangle. 63 degrees, x and 8. Okay, so here's the angle. This is adjacent and opposite. What do I use? Tangent. So tangent of 63 degrees is equal to opposite over adjacent. So x is equal to, so you gotta multiply the x on this side and you gotta divide the tangent 63. And then you guys can punch that in on your calculator, right? I'm assuming. And then D, look, that's a part. You guys get second chance tomorrow. X, 9, and 5. Okay, now here's the angle. This is opposite, and this is hypotenuse. What do I use? Sine. So the sine of angle x is equal to opposite over hypotenuse. And then how do I find what x is? Sine inverse. 5/9. Because remember we just did this last chapter, right? What does that mean? Sine of what angle is 5/9? Punch that in a calculator and please round off correctly. Can do? Alright, so first page easy. Breeze through that thing. And then now we gotta compute areas. So what are the formulas you need to know tomorrow? And I'm not gonna give them to you. You only gotta know two.
S equals rate Herman.
Okay, so Heron's formula. Heron's formula. Square root of S, S minus A, S minus B, S minus C. And everybody knows what S is, or do I have to write that down? I'll write it down. S is half the perimeter, or as the book calls it, the semi-perimeter. And then what's the other area formula? 1/2 AB sine C. So if you are given all three sides of a triangle, this is what you use. You use Heron's formula to find the area. If you're given two sides and the included angle, then you use this formula to find the area. So in problem 3A, look how simple this is. Poco, poco, poco. The only thing different tomorrow, I haven't changed the numbers. How about 5, 3, and 6? Maybe I should put decimals in there since you guys have calculator. Why would how? Whatever. Okay, so since I'm given three sides of the triangle, I'm going to use Heron's formula. So the first thing I should do is figure out S, the semi-perimeter. What is the semi-perimeter? What is 6 plus 4 plus 7 all over 2?
17 over 2.
17 over 2. And when you punch that in on your calculator, you probably want to use 8.5, yeah? Whatever, you can do 17 over 2. And so, the area of this triangle is simply the square root of S, which is 8.5, times 8.5 minus each of the sides. So 8.5 minus 6, 8.5 minus 4, and then 8 minus 5, 8.5 minus 7. Punch that in on your calculator, spit out the answer. See how easy? You can breeze through this test. Okay, B. Where's B? Whoop, whoop, bow! 123 degrees, that's 4, that's 5. So if you're given two sides and the included angle, then how do you find the area? You use this formula. So the area of a triangle is simply 1/2 the product of the two sides times the sine of the included angle right there. Boom, punch it in on your calculator. So what's the hardest part of this test? Memorizing the four formulas. That's not hard. Memorizing is like the lowest form of intelligence, I heard. Right? Because you don't have to apply, you just gotta memorize, right? Okay, now you gotta apply. Compute the area of some quadrilateral. This is where the fun begins, man. I just thought of a problem by looking at this. I don't know if I'm gonna give it to you. So, 8, 6, 7, 8, 9. How creative. Okay, find the area of this quadrilateral. So we know how to find the area of triangles, so you want to split it up into two triangles. So which diagonal should I draw in? Should I draw A or B?
A.
Actually, you can do it either way, but one is going to make it a lot easier. Which one?
A. You can
A, because you have a right triangle, right? Right triangles are easy to work with. So what's the area of this triangle right there? 1/2 base times height, right? 1/2 6 times 8.
24.
Yeah, but you didn't have to know that because you can just punch it in on your calculator, right? Plus, now, how do I find the area of this triangle here? Well, I have to know two sides and the included angle, all three sides. Well, I know two of them. If I could just figure out this one right here, I'm done. Well, if you have a right triangle, if you know two legs, how do you find the hypotenuse?
10.
You use the Pythagorean theorem. So look at that, 6, 8, 10, because that's a 3, 4, 5 triangle, right? So what, tomorrow, 5, 12, 13? Or you know what, maybe I'll make it come out of radicals and see if you can punch in a radical on your calculator. Like 6, 7. What if this was 6 and 7? What would that be? 36 plus 49. Radical 85. Can you guys handle that? I think you can. Anyway, so if you have the three sides of a triangle, what's the fastest way to find the area? Heron's formula. So the first thing you do, compute the semi-perimeter. What is 10 plus 7 plus 9 over 2?
13.
You're right, it's 13. So the area of this triangle is the square root of 13 times 13 minus 10 times 13 minus 7 times 13 minus 9. And if you want to simplify each of them like 3, 6, and 4, you can, but just punch it in. So you write this down on your paper, you're going to get almost all the points, and then the last point is, can you punch it in on the calculator? That's not that hard. Okay, B is a little tougher, that's why it came second. Buku, buku, hangga, 2, 7, 5, 6, and 111 degrees. So, how should I draw the diagonal in? Should I go A or B? Which one's easier? A. You know why? Because you got a right triangle. When you have a right triangle, things are just easier. Next chapter though, you're going to have the same problem, except that's not going to be a right angle. Same thing here. Not going to be a right angle. Then what do? Then we got to use other formulas. Okay, so, right here you got a radical. So, what's the area of this triangle? 1/2 base times height, right? Because this is a right angle. So that means that's the base, that's the height. Easy. Okay, but how do I find the area of this triangle? I got this side, and see now, I don't know what that side is. Can I figure out what this side is? Yeah, because look, if this is 7 and 5, how do you find this side? Pythagorean theorem. Okay, why don't we call this x? So using the Pythagorean theorem, I'm going to erase this thing. Using the Pythagorean theorem, x squared is equal to 5 squared plus 7 squared. What is that? 25 plus 49, and that's equal to 74. So x is equal to the square root of 74. See, you're gonna have to work with radicals. So we just figured out that this is radical 74. So in order to figure out the area of this triangle, I gotta either figure out this side or that angle.
Side.
How do you do that then? Tell me.
Use the diagonal.
This is not a right triangle though.
Oh yeah, that's true.
You can only use the Pythagorean theorem if it's a right triangle. That's not a right triangle.
Alright, triangle.
So can I figure out this angle?
You could.
Yes, because can't we figure out this angle right here?
Yes. 'Cause it's a-
Okay, here, let me show you. You have a right triangle right here. Let's call this angle theta then. How can I figure out theta? Well, this is the adjacent side, this is the opposite side. Which one has opposite and adjacent in it? Tangent. So tangent of angle theta is equal to opposite over adjacent. Therefore, theta is tan inverse 7/5. Punch that in on your calculator. What does the answer say? Okay, I'm going to get my calculator. I'm going to show you something here, because this is where some of you are going to make rounding errors. So I take out my calculator, which is in degree mode. I'm hoping that's it. Always gotta check. Where's my mode button? Yep, I'm in degree mode. Okay, so tan inverse 7 divided by 5. Woo! So theta is equal to 54.46232221 degrees. You need all the decimal places now. Don't round up to only 3. Because you get rounding errors.
Wait, so technically if we just...
If you're just gonna write down the answer, then you put 54.462, right? But if you're gonna use this in another computation, which we are, then you gotta use all the decimal places. Or at least 5. At least 5. Okay, because if this angle is theta, how do I compute this angle right here? If the whole thing is 111. Wouldn't it be 111 minus that?
Yeah.
So on your calculator, now, you go 111 minus, now, instead of punching this in again, is there a way to tell my calculator to just spit it out?
Yeah, you just hit the up button.
Answer.
Answer.
There you go, very good. Answer!
The answer button.
Look for that button on your calculator. The answer button is the last thing that you computed on your calculator. So since it was that, so you just tell your calculator 111 minus answer. So now I tell my calculator 111 minus answer, whoo! I get 56.53767779 degrees.
Wait, you subtract answer?
Here, 180. Because look, if this angle here is that, and the whole thing is 111, how do I find that one? You subtract, right?
I have 45.
What?
Oh, wait.
Just do it in your head. 111 minus 50 something, how do you get 40 something? That's gonna be impossible.
Yes.
It's gonna be impossible. Okay, now we know this angle here. This one is 50 here. This is 57.5300. So, how do I find the area of this triangle? Okay, now I gotta come down here. 1/2 AB, so 6, times root 74, right? Times the sine of this angle, but you need to use all the decimal places. You cannot just round off to 3. This is where you guys are gonna get in trouble. So you gotta write 56.537779 degrees. You guys understand the concept? This is not chemistry where we're doing sig figs now. This is math. So if you're gonna use a number in another computation, you gotta use all the decimal places. Or at least 5, since we're rounding to 3 places. And please round off to 3 places, because some of you only gave me 2, I don't know if it was this class or another class. And you know when we grade AP exams, everything is supposed to be 3 decimal places. What happens if you only give 2 like that? 52.78.
It's wrong.
No, we just assume the third one is 0.
It's wrong.
Well, not if it's 0. So you have a 1 out of 10 chance, right?
Yeah.
It's a 1 out of 10 chance, it might be correct. Anyway, the directions on tomorrow's test is round up to 3 places. So if you don't, I laugh at you. Okay, so everybody can do that problem? That's probably the hardest problem so far, because there's a radical, and then you gotta use decimal places. Okay, and then, okay, we did this on the homework. We're doing it. I told you it was gonna be on the test. So you got a circle, and then, what's this? 3, 3, except that's 130 degrees. Am I reading that correctly?
Yes.
Yeah. 130 degrees. Find the area of the shaded region. What is the shaded region called again? Well, you don't even know. It's called a no. It's called a segment.
Segment.
Maybe I should put that on for bonus.
Yeah.
That's not gonna happen.
You should.
Okay, now, how do you find the area of this segment or the shaded region? See, like I just said, shaded region.
The sector minus the.
Yeah, so you take the area of the sector, which we know how to do, and then you subtract the area of the triangle, which we also know how to do, right? So how do you find the area of a sector? We use this formula. Here, I just erased it.
R squared theta.
1/2 r squared theta, but you gotta remember, theta gotta be measured in radians, right? So, 1/2, what is the radius? 3 squared times theta. Now, 130 degrees is not radians. How do you convert degrees to radians? You gotta multiply by pi over 180. What happens if you put 180 over pi tomorrow?
Then I laugh at you.
No, just minus 3, unless it's 4. Minus the area of this triangle now. How do you find the area of a triangle if you know 2 sides and the included angle? Where's the formula? It's not there. The area is 1/2 AB sine C, right? That's the one you want to use. So 1/2 AB, 3 times 3, times the sine of this angle, which is 130 degrees. Now you just punch this in on the calculator. Good. Canada? I'm just curious to see how the homework is going to be when I check it. In fact, I'm going to make a resolution right now. I'm going to check homework the rest of the time, the rest of the quarter.
Oh.
Yes. And remember, each problem not done correctly is -1 now. That's how it's done. So some of you can get negative. But once you hit 0, I don't go anymore. Okay, you see number 6? I wrote that problem when I did the practice test, but I'm not sure if I'm going to give you this on the test. I might change it.
Google.
I wanted to name my firstborn Google, but my wife said no. So we had to name her Jody. No, for real. For real. What? What's wrong with Google? You guys know what Google is, right?
Yeah.
What?
internet source?
Search database.
No! That's Google. I'm talking about Google.
Oh, with the GOL.
Yeah, Google is the search engine, whatever. Google, that's the one followed by 100 zeros, right?
Oh, yeah.
You know, Google.
Yeah.
It's a one followed by 100 zeros. It's called a Google. How can you not know that?
That's something that's old for me. I don't remember that.
I'm gonna name my kid Google. Google, yes, but not Google.
If you named it Google, it would be
Everyone's gonna
Moto.
think, when they hear the name, everyone's gonna think Google.
Not when you see the spelling.
No, they're just gonna
Our
think,
boy.
they're just gonna think that, yeah, you spelled it wrong.
Hey, did you see, there was a soccer team last week, and on their jerseys, they had math instead of like regular, instead of number 9 on the back, they had like 6 plus 3. Did you guys see that?
No.
It was a soccer team, I don't know what league they were playing with. So it's, yeah, but it was all simple kind, like 6 plus 3, 7 minus 2. They didn't have stuff like 3 squared, or log base 2 of 8. You know what I mean? Or secant pi over 3.
Gosh.
It was all like just addition, subtraction, so it was a good thing, but didn't go far enough.
That's funny.
Okay, anyway, what are we trying to find in this problem? We're trying to find y.
What?
Trying to find y, this thing here. Well, let's call this distance z right here. If I knew x and z, could I figure out y?
Yeah.
Yeah, you just subtract, right? The big minus the small. So let's figure out z. How can I figure out z? Look at this triangle right here. I'm trying to figure out z. Here's the angle. This is opposite and this is adjacent. So what do I use?
Tangent.
Tangent. So tangent of 42 degrees is equal to 25 over z. So this is like just like page 1, except you gotta do like put 2 of them together,
V
right?
equals 25 over tangent 42.
Yes. Punch that in on your calculator.
Oh.
But I'm just gonna wait till later. Okay, now, look at the big triangle here, the big red triangle. How do I find x? Well, this is 26 degrees, this is opposite, and this is hypotenuse, so again, I'm gonna use tangent, right? So the tangent of 26 degrees is equal to opposite over adjacent. So therefore, x is equal to 25 over the tangent of 26 degrees. Now, if you want to punch this in and punch this in on your calculator and then subtract them, you can, but you know what's better?
Just subtract.
Just do this. Tangent 26 degrees, that's x, and I subtract z, 25 over tangent 42 degrees. And then just read what your calculator says, so you don't have to write anything down, you know what I mean?
Can't you just subtract the tangents and divide by that?
Say that again.
Subtract the tangents and divide by that. No.
Wait,
What?
wait, let me look. No. Where did that come from?
I have no clue.
If you know the big length and the small length, how do you find this one? You subtract them, right? Okay, so see, it's better to do this, because if you compute this and then you're going to compute this and you're going to punch it in all again, you know what I'm saying? See, so you just go 25. I'm trying to teach you the tricks of the trade. Divided by tangent 26 minus 25. Oh, you mean factor out the 25. Is that what you meant?
Yeah.
Yeah, you can factor out the 25 if you want. Divided by tangent 42, and you get 23.492. See, and if you do it this way too, you don't have to worry about rounding errors, you know, like using all the decimal places. Just let your calculator do all the work.
I don't like this problem.
Yeah, you know what okay, this is what I woke up in the middle of the night last night and I was thinking, I don't like this problem. So I said, what problem can I replace it with? And then I was thinking, you know the homework problem that you asked me about? I did it on the board. Here, I'm just gonna tell you right now. Remember that problem? There was a plane. Does that sound familiar?
Oh.
And then it traveled like this distance here, like it was from the north, it went 37 degrees east. What, what's so hard? I don't know what's so hard about that.
Oh no, this part.
Why, we did it on the homework?
Yeah, but this one's
Can you just keep
better.
this one, please?
No.
Oh, that part.
So I think it went for like half a mile, but then I'm gonna change it to like 2 miles or something.
Oh.
And then it made a 90-degree turn, and it went for, in the book it was 1 mile, so I'll say 3 miles.
Or
Okay, so from the airport, what was the direction of the, to find
What?
the airplane,
No, but your
remember?
wording
That's
is
scratch.
different. It's like.
No, I'm just gonna take the book and type it in exactly and change the numbers.
Oh.
Why? You did it for homework, we did it on the board.
Smart.
So,
Page back.
yeah,
I like that problem.
no, I like this one.
I like
If
that.
I'm gonna wake up 2 o'clock in the morning to think about something, it's gonna be on the test.
What's your first part?
It was nightmare.
What does this have to do with it?
Just keep it.
Oh, cause that was in the problem. Okay, Google is at the airport.
Oh,
She
smart.
travels 2 miles in this direction. Then she makes a right angle turn like this for 3 miles. What is the bearing of the airplane now?
Are you gonna draw that
Google
for
is
us?
traveling in?
Are you gonna draw?
No, this is on the homework problem, they didn't give you a drawing, right?
Which one is it replacing?
The
This
southeast.
one.
Bubble.
Southeast.
Oh man.
Or maybe I'll just come up with a different, whole different one.
Yeah, they're.
I don't understand, look. Let's go. Okay, here, let's do this, let's just do this for fun. Let's do this for fun right now, we got it on video. So, from the north, you go 37 degrees east, so this is 37 degrees. Okay, so what we need to do is now, we need to figure out the direction of the airplane, that's what we need to figure out. So, basically, we need to figure out this angle right there. Now look, let's call it, I'm trying to teach you something here, since you guys didn't listen the first time on the homework. If you have it's a right triangle, see, if it's not a right triangle, then at this point we can't do it. Next test we can do it.
How would
This
you
test,
make it?
it's gotta be a right triangle. So look, this is opposite, this is adjacent, which one do I use?
Tangent.
So the tangent of angle theta is 3/2. So therefore theta is tan inverse 3/2. Now we'll punch that into my calculator now. Tan in, okay.
Wait, why do you make it tan inverse of the opposite?
Because that's how you punch it in on your calculator to figure out the angle. You have to go tan inverse. We've been doing this for weeks already.
No, but I just don't understand why.
We've been doing this for weeks.
No,
Because we're trying to find the angle. See, if you're trying to find the side, like here, if you're trying to, yeah, see, look, if you're trying to find the side, then you just do this. But if you're trying to find the angle, Chan, then you gotta use tan inverse, cosine inverse, or sine inverse.
Also, on the side, did you just punch it in like that?
Yeah.
Oh, okay, I see.
Are you doing the homework?
I am, I just didn't understand why you did it like that.
But even if you didn't understand it, you saw me do it. Like, I don't understand why I have to clean my toilet. But you just do it, right?
But they're hard.
Sit down. Sit down. Okay, so you punch that in on your calculator. 3 divided by 2. So you get 56.30993247 degrees. So that's what this angle is. But we have to give a direction. So what you gotta do is, you gotta draw this horizontal line in. Now, if this angle here is 37 degrees, what's this one over here? If this is 37, what's this one right here? They gotta add up to 90 degrees, people. 53 degrees. Now, if this angle here is 56 point something degrees, and this angle is 53, how do I figure out this one there? You subtract. So you take this number and you subtract 53 degrees. Minus 53, and I get 3.309932474 degrees. Correct? Yes. So now you gotta give that in a direction. So from the east, I'm gonna go this many degrees, which direction?
South.
So 3.310 degrees south. Bam! What's so hard about that? Okay, what if I give you the picture then?
Okay, yeah.
Okay, or from the south, Izuo wants to do this, Well, if this angle is 3 point something degrees, how do I find this angle here? You subtract it from 90 then, right? So what is 90 minus this? 90 minus answer. See, the answer button is a godsend. 86.690 degrees. We're not using it in another computation. So you can also go from the south, go 86.69 degrees east. See, if you're at the south, you're either going to go east or you're going to go west. That one is east. If you're east, you're either going to go north or south, right? What's up? What? This is the kindergarten I learned this. I was in kindergarten. Okay, number 7 now. Find the area of a regular, okay, I'll tell you what. Since you guys look so perplexed, I'll give you, what if I give you the picture?
Yeah.
I can give you the picture, but I'm not gonna draw in the angles. You're gonna have to draw in the angles yourself.
So,
Okay, I'll give you that one then.
no, how about
It's kinda sad.
number 6?
No, I don't like, I told you, if I'm gonna wake up in the middle of the night and waste time sacrificing my sleep, I'm replacing it.
But then we're gonna wake up in the middle of the
There you
night.
go, yeah, go ahead. Here, why don't I take a picture now? See, good idea.
Wait, what's what I
See? That's what you should do. Or what if I fake you out and just go back to the Google problem?
said? So messed up.
Okay, 7. Find the area of regular decagon. Okay, so tomorrow, we're gonna have the same problem, except instead of 10 sides, I'm gonna make 9 sides or 11 sides or 12 sides or something. Okay, so 10 sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's pretty ugly. But it doesn't matter. So what's the strategy of this problem? Find the area of, see, because look, if you draw all of these in, you have 10 triangles, right? If you just find the area of one of them, don't you just times that by 10? Or so tomorrow, what if it's 12 sides? Find the area of one of them and times it by 12, right?
Yeah.
Okay, so how do I find the area of this one triangle there? Do I know how to find the area of a triangle? I think so. Okay, so what do we need to know? It says the perimeter is 36. So what is, if the perimeter is 36 and there's 10 sides, how do I figure out one of the sides?
Divided by 10.
36 divided by 10 is 3.6. Okay, there you go. Now, how do I find the area of this triangle right there? 1/2 base times height. Okay, what is the base? 3.6. Okay, the key to doing this problem is you gotta figure out the height. Or if you guys remember anything from geometry, that's called the apothem. Okay, find the height. How do I do that, Mr. Park? Well, do I know like one of these angles here? There's 360 degrees in a circle, and there's 10 sides. So what's 360 divided by 10?
36.
All right, 360 divided by 10 is 36. So this angle here is, so each one of those angles is 36, but when I draw the altitude down like this, that means this is half of that, which is 18 degrees. And why do I do that? Because you have a right triangles, you can use SOHCAHTOA, right?
Oh, sweet.
So if this is 3.6, and then you draw this in, and it cuts it in half, then wouldn't this be 1.8?
Yeah.
So look at this right triangle right here. I'll shade it in right here for you. Here's the angle. This is opposite, and this is adjacent. What do I use?
Tangent.
Tangent. So the tangent of 18 degrees is equal to opposite over adjacent. Therefore, height is equal to 1.8 over the tangent of 18 degrees. That goes right there, right? That's the height. So this is the area of that triangle right there. But then you got 10 of them. So you just times it by 10. Can do it. Just remember though, if you punch this in on your calculator, you gotta put all the decimal places over here now. So if I were me, I would just leave it 1.8 over tangent 18 and just punch everything in this. That's what.
9.971.
I'll got the answers right too. Okay, and then the last problem. We're almost done. And then again, we are not going on to the next section. Tonight's homework is study for the test. You guys are so lucky you guys got that. See, aren't you glad that we're ahead of the other class? Because if we weren't, then we couldn't do this. Tonight's homework would be the first section of the next chapter. Yeah, I'm pretty sure I'm gonna change it to that. Look, I'll even make it, I was thinking I should put it on this side, but instead of going east, you go west. Is that gonna throw you off?
Yeah.
That's so sad. Okay, here's another, find the area of the shaded region. So the radius of the circle is 4. This is 57 degrees. Find the area of the shaded region. So, what's the strategy for finding the area of the shaded region? This is a right angle here, yeah?
Triangle minus sector.
Triangle minus the sector. Simple geometry, right? So now, how do I find the area of a triangle if it's a right triangle? 1/2 base times height. Yeah, but Mr. Park, I don't know the height. Well, we can figure it out because it's a part of a right triangle, right? So, look at the right triangle. If this is 57 degrees, this is opposite and adjacent. Which one do I use? Tangent of 57 degrees is equal to opposite over adjacent. Therefore, the height is 4 times the tangent of 57 degrees, correct?
Yeah.
You can punch that in, but I'm not gonna even bother. So therefore, the area of this triangle is 1/2 base times height, which is 4 times the tangent of 57 degrees. See, just leave it like that. Don't punch it in. Let your calculator do all the work. And then I have to subtract the area of this sector.
So you,
What's the formula for area of a sector?
1/2 r squared theta.
There you go. So minus 1/2, the radius is 4 squared. Theta is 57 degrees.
Doesn't have to be in grade.
Very good. That would be a -4 error probably. The angle must be measured in radians. So if it's given in degrees, then it will be, right? Because that's how it is on the practice test. You need to multiply that by pi over 180. See, you just write it down like this, and then now you take out your calculator and just punch it in. You know what I'm talking about? Let the calculator do all the work. You don't have to write down any decimals or anything. All right. So we are done. So you guys have 13 minutes left, and then I can change that problem on the test paper. Oh, yeah. All right. And I don't know if some of you guys know the solutions are here. All right. And don't forget the stuff because this stuff is going to come up on the next chapter.